To be able to display fonts where you want them in a Java window, you'll need to know how fonts are measured and sized. Now, while it's true that text is the thing that's displayed most often, and lots of displayable fonts are available in Java, it's one of the most difficult things to position on the screen until you understand how it's measured. Once you can measure it, you can position it. Now, the letters of Java rest on a baseline that runs along underneath the bottom of every letter. Well, as you can see in this example, it runs along the bottom of almost every letter. Some letters have descenders that extend below the baseline. Now, the distance from this baseline to the bottom of the lowest extending letter in the entire font is known as the descent of the font. Not all letters have descenders, of course, but you need to allow for the ones that do when you're positioning a line of text. Just like some letters have descenders, some others have ascenders. The ascent value is the distance from the top of the tallest letter in the font to the baseline. Now, some characters have very short ascenders, and most have no descenders. Some have very short ascenders and descenders. For example, a comma has a very short ascender, and while it has a descender, it's quite small. Notice now that the sum of the ascent and descent is the height of the visible portion of the tallest possible character in the font. Also notice that the height of the characters vary from one to the other, and that the baseline is almost never in the center of text, or even in the center of a single character. This fact becomes important when you are trying to position text vertically. Every character has a width, which includes the white space necessary to separate it from the characters to its left and right. Some fonts have the space on the left, some on the right, some on both sides. Exactly how this is done is entirely up to the designer of the font. In most modern fonts, the width of the characters vary. It doesn't show up very well in this example, but the width can vary quite a bit. For example, the letter W is much wider than the letter I. A few fonts have all the characters take up the same width. These are known as fixed fonts or fixed width fonts. Anyway, the variable width characteristic of fonts means that the graphic length of a string of characters cannot be determined by multiplying some width value by the number of characters in the string. The space between the lines of characters is called the leading. The name comes from the old practice of placing thin strips of lead between lines of type when setting the type by hand. The value of the height of a font is measured from the top of the tallest ascender to the bottom of the leading. Once you determine the height, you can display multiple lines of text, one below the other, by adjusting the vertical position by the value of the height of the font. Now, here's an important point for positioning text. Whenever your code specifies the location of a character, it specifies the location of the baseline immediately to the left of the character. In displaying a line of text, the position of the first character on the line is specified. The position is always at the leftmost end of the string of characters and on the baseline. In the next 3 lessons, we're going to look at the techniques of creating fonts and determining the measurements so we can display them where we want them in a window. This lesson will show you how to create a window and draw a line of text into it. The window is displayed as a frame object, just as we did with the previous lesson that displayed a label. In fact, this class is identical to the one that displayed the label, with a single exception that a text1 object is displayed instead of a label object. Here a declaration is made for the location that is to hold the address of the text1 object. And here, the actual text1 object is created. And finally, just as we did earlier with the label object, the text1 object is added to the frame for display. Then the pack and show methods are called. So the only question that comes up is, just what is a text1 object? Well, it's not part of the standard library like the label was. This is a class of our own. It's very simple, class. A canvas object is a displayable component, just like a label, except the canvas object doesn't do anything but provide a blank window and permission to draw graphics of our own. So, the text1 class extends the canvas class and adds a method to draw a single line of text. The paint method is called by Java whenever the text1 object needs to be displayed. That is, whenever the text1 window first appears, the paint method is called to draw the content of the window. The paint method is called again whenever the window changes sizes or is uncovered from behind another window or anything else happens that makes it necessary to redraw the window. All right, here's what happens. Inside Java, it's determined that for whatever reason, the window needs to be displayed. The window's cleared if it isn't already clear, and a graphics object is created. This graphics object contains the information on the window itself and all the methods and information you need to draw things to the window. Then a call is made to the paint method of the text1 object so the content of the window can be drawn. In a future lesson, we're going to be looking into more detail on calling methods and passing things to them, but for right now, just be aware that a graphics object is being passed to the paint method, and that we've assigned a local name of G to the graphics object. We could have made up any local name we want, but I like to use G because it's short, and the graphics object is used a lot inside the paint method. In this method, we don't do much in the way of graphics. We leave the background and foreground colors to whatever the default happens to be. We don't even check the window size or specify the font. We just display a string of text at a fixed location. Now, to specify the location of an item to be displayed, it is necessary to specify its X and Y position. The X position, which is the horizontal location, is the number of pixels from the left side of the window. The Y location is the vertical position. It's the number of pixels down from the top of the window. In this example, the location of the string is 50 pixels from the left and 100 pixels from the top. The constructor of the text1 class has only one statement. It's a call to set size. This method is of the canvas class, so it's inherited by text1. Actually, the canvas class inherited the method from the component class because the canvas class extends the component class. Anyway, the set size method specifies the original size of the window. Now, these two classes can be compiled with a single statement, like so. This command will actually compile every Java program in the current directory. You could just as well compile each class individually from the command line, but I kind of like to hand them all to the compiler and let it sort things out. Anyway, we wind up with a source file and a class file for each of our classes, and you can look at them with a dir command like this. Now we should be able to run the program with a single command like this. And the window appears. Notice that it's not necessary to use an import statement in this case because the text1 class is in the same directory. Java will always look in the current directory to find names that you use. The import statement is only necessary if you want Java to find classes stored in other locations. Now, notice what happens here. If we expand this window, notice that the text always appears in the same location in relation to the upper left corner of the window. Now, in the next lesson, we're going to be looking into detecting the size of the window and positioning the text accordingly. This lesson will show you how to draw a line of text in the center of a window. The window can be resized and reshaped, and the text will automatically shift positions to remain in the center. Just as in the previous example, this class extends the canvas class to create a window into which we can draw the text. Now, the constructor of text2, just as text1, sets the size of the window to be displayed. The only method declared in the class is the paint method that will be used to calculate the position of the string and display it in the window at that position. To be able to center text in a window, we have to know the size of the window. The information is available, but it comes in the form of a rectangle object. Now, this statement, rectangle rect, declares the location to store the address of a rectangle object. By the way, the location used to store the address of an object is called the reference. It's called that because once the address is stored there, it's the name of the reference that's used to refer to the object. In Java, you never address an object directly. You can only refer to an object through the name of the reference to that object. This statement is a call to the getBounds method of the Canvas class. Inside this method is a new statement that creates a rectangle object containing the height and width of the window. Whenever an object appears in Java, there is, somewhere, a new statement that created it. The only way to create an object in Java is to use the new statement. This is another reference. This statement is the declaration of a reference to a string object. The string object is very special in Java, and we'll be exploring it in some detail soon, but for right now, you just need to know that it's a special object and contains a string of characters. And you can create a string by simply inserting a quoted string of characters in the code. Now, this statement creates a string object and stores its address in the string reference. You don't have to say new here because Java does it for you. More in the string object and its magic a little bit later. Each font has its own set of measurements. The font definition itself is stored inside the graphics object, and the graphics object has a method named getFontMetrics that returns the FontMetrics object that contains all the measurements of the font. Notice here that the reference to the FontMetrics object, named FM, and the call to the method that returns the FontMetrics object are on the same statement. The previous code, creating the rectangle and string objects, were split into 2 lines each, but they could just as easily have been written on 1 line like this. The resulting code is the same, it's just a matter of how you prefer to write it. But it's important that you remember that 2 things are being done. First, a reference is being declared, and second, an object is being created, and its address is being stored in the reference. The FontMetrics object contains all the information on the width of each character in the font, so the string width method can be called to look through a string of characters, add up all the widths, and determine the length of a string. We need this information so we can figure out where to position the beginning of the string in the window. The value of y is to contain the vertical position of the string. We want to center the text vertically, so we can set the value of y to half the height of the window. The baseline will be displayed at this height. Now, I know the baseline is not exactly in the vertical center of the text, but it's close enough for this particular application. If you wish, you can get the ascent and descent value from the FontMetrics object. By doing a little algebra, figure out exactly where the center of the string should be and where the baseline should be placed to center the text. But the difference will only be a pixel or 2 in this example, and it's really not worth all that effort. The horizontal position of the string is slightly different. We need to do a little algebra here to figure out the position of the left end of the string. We start with half the window width, which is where we want the string to appear, and subtract half the string width, which is where we want the string to begin. And finally, we draw the string. The str argument contains the actual characters to be displayed, while the x and y values contain the position of the window. And that's all there is to it. This command compiles the programs. The programs are text2 and showText2. The main line of the program is showText2 and is exactly the same as showText1 from the previous example, except this one displays a text2 window instead of a text1 window. The program is run like this. And the window appears. The text is in the center. Expanding the window causes the text to remain in the center. Stretching the window horizontally and vertically will cause the text to reposition itself to remain in the center. Each time we release the mouse by resizing the window, the paint method is called and the calculations are performed to determine exactly where the text should appear so it appears in the center of the window, no matter what its shape. This lesson will show you how to position a line of text using the ascent and descent values, as well as using the string width. The window can be resized and reshaped, and the lines of text are going to automatically shift positions to remain against the edges and in the corners. Now, the constructor of the Text3 class specifies the size of the window to be displayed. The paint method is used to calculate the position and display the 4 strings, one in each corner of the window. The strings are displayed flush against the corners without margins. A call is first made to getBounds to get a rectangle object containing the height and width of the window. A call is then made to getFontMetrics to get a FontMetrics object containing the measurements of the font and that can be used to determine the graphic lengths of each of the individual strings of characters. Next are the declarations of some of the variables that are going to be used more than once when displaying the strings. Because they're going to be used several times, it makes sense to declare them at the top. You could wait and declare them where they're first used, but I like to do it this way to indicate that they're being used throughout. It's your call, just a matter of style and preference. This is the string of characters that we want to display in the upper left-hand corner of the window. We don't need to know the length of the string. The left end of the string is going to be up against the left side of the window, so the value of x is 0. We want to put the tops of the tallest characters directly against the tops of the window, so the baseline will need to be the distance of the font's ascent from the top. Since the vertical position of 0 is flush against the top and the distance value increases downward, setting the vertical position to the ascent value of the font will place the baseline so the top of the font will appear against the top of the window. The specified string is drawn in the calculated position. This string is to be placed against the top of the window, but on the right side instead of the left. This time, the length of the string is necessary, so we can place the start of the string in such a way that the end of the string winds up flush against the right side of the window. The value of y, which is the vertical string position, is again set to the ascent value of the font. The value of x, the horizontal position, is calculated to be the total width of the window less the length of the string. When the string is drawn here, it will appear at the top of the window with its right end flush against the right side of the window. This string is to be placed on the left side of the window flush against the bottom. The horizontal position of the string is set to 0. The vertical position of the baseline is calculated by taking the height of the entire window and subtracting the descent height of the font. Nothing new here. We use the same techniques as before to place the string on the right side of the window and at the bottom. The vertical position is determined by subtracting the font's ascent value from the total height of the window. The horizontal position is determined by subtracting the length of the string from the total width of the window. And the window appears with all 4 lines of text. Resizing and reshaping the window causes the text to adjust its position so that it remains in the 4 corners. You may notice that the strings don't necessarily appear directly against the top and bottom. There's more than one reason for this. The font may not have been created with enough of its ascenders and descenders extending all the way to the top and bottom. Also, it could be that this example doesn't use the highest or lowest ascenders and descenders in the font. Also, it's possible that the particular windowing system that you're using always inserts a boundary around the window it produces. This happens in some windowing systems, but is seldom more than a pixel or 2 wide, and it only appears around the edges. Now, The next lesson, we're going to be looking into selecting some fonts and some colors. One of the best features of Java is its garbage collection. As a Java programmer, you almost never need to concern yourself with memory management. It's handled for you. To show you what I mean, let's take a look at the text2 class from the previous lesson. Inside a method, whenever you declare a reference, as is done here with a rectangle, the space for it is allocated locally and only exists while the method is being executed. Once the method returns to its caller, the reference is deleted and the memory it used is available for other parts of the program. Objects, on the other hand, are allocated space from the free pool of memory, and that memory will remain dedicated to the object only as long as there is at least one reference holding its address. Once no reference can be found to an object, the system reclaims it. Now, as this program runs, the paint method is called again and again to draw the string. Each time it's called, the getBounds method is called, and it creates a new rectangle object. There is no code to delete the rectangle object because Java handles that for us automatically. When the paint method completes its task, the reference name rect, holding the address of the rectangle object, is returned to the system. Java notices that fact, and notices the fact there is no longer a reference anywhere to the rectangle object, so it reclaims the object and recycles the memory that it was using. This process is known as garbage collection. You can create all the new objects that you want in your program, and Java will come along behind you and clean them up. All you have to do is forget about an object, and it automatically returns to the system. This makes it difficult to write a Java program that accidentally expands and hogs computer memory. A bug like this is known as a memory leak and is quite common in other languages that use dynamic memory allocation, such as C and C++. Garbage collection is one of the most attractive features of Java. It makes life very easy when you don't have to clean up behind yourself. All you have to do is forget about something and it's automatically reclaimed and recycled. The process of garbage collection is recursive. That is, if you no longer have a reference to object A, it is reclaimed by the system. If object A, in turn, contained a reference to object B, then it is also reclaimed. This process continues until every bit of memory that you can no longer access is returned to the system and is available for use by the next new statement. Now, all of this takes place while your program is running, so you'll see discussions on the efficiency of garbage collection. You may also come across discussions comparing one garbage collection algorithm to another. The garbage collection routines in the Java virtual machine today are much faster and more efficient than the ones that were in there when Java was first released. In this example, the paint method is called every time the window is updated, and three objects are created. They are the rectangle, the string, and the font metrics object. When the paint method finishes, the references are all returned to the system, so the objects are all recycled. But all this happens very fast. The memory allocation and reclamation routines are fast enough that you can ignore them. It's a very rare situation that requires that you do something to reduce the amount of garbage collection. Generally, this sort of problem only arises in time-sensitive real-time processing, and even then it's considered better policy to make the thing work first, then come back and speed it up. Java has lots of fonts to choose from. In a later lesson, I'll be showing you a simple program that you can use to get a complete list of all the fonts available on your system. Right now, I'm just going to use some of the standard fonts that are always installed. The font text class extends the canvas class to construct a window that can be used to display several lines of text in different fonts. Now, fonts are created as Java objects. So, you'll need to name the font class on an import statement so the compiler will be able to find the class when you refer to it. The paint method of this class does nothing more than create a series of font objects and display the string using each one. In each case, the string displayed is a description of the font itself. The new keyword is used to create the font object. A font object must be created for a specific font name. Actually, the name is that of a family of fonts because Inside the family, as we'll see, there are fonts of the same name that are different size and have a slightly different appearance. The font constructor requires that you specify one of 4 possible appearances for the member of the font family that you've selected. The text can be displayed in just plain form, or it can be designated as being bold or italic. Now, it can be designated as being both bold and italic by specifying both names and placing a vertical bar between them. The vertical bar is the bitwise OR operator, and we'll be getting into all of those details a bit later. You must also select the font size. Now, this is a bit odd. Every measurement of everything displayed in a Java window is in terms of the number of pixels it takes up on the screen. Fonts, however, are specified as a number of points, and a point is 1/72 of an inch. So, if you specify a font as being 12, you're saying that you want it to be 12/72 of an inch. Between you and me, this thing with points is a problem looking for a solution. Java sort of inherited the whole thing from the operating systems on which it runs. The size you specify is actually translated into a number of pixels at some point, and it will change sizes when you change screen resolution, so it really isn't measured as part of an actual inch. I mean, the Java program may have no idea how big your screen is. Anyway, because it's measured in points, you'll find that you have to kind of experiment with the size to get it just the way you want it. Oh well, can't have everything. The drawString method is used to actually display the string. But, if you'll see, the drawString method does not provide a way for you to specify the font. To specify a font, you must put it into a graphics object with a call to set font. The graphics object only holds one font, so you'll need to store a new one there every time you want to use a different font. Not only that, but the graphics object has its own default font already installed, and it won't remember any font that you store into it from one call of Paint to the next. This is true because you get a new graphics object every time Paint is called. To give you a fair idea of how all this works, this program selects several different fonts in different sizes. Notice this last one. This is to show what happens when you specify a font name that is completely unknown. When you do this, Java makes a new copy of its default font and uses that. This means that when you mess up the name of your font, you don't get any sort of error message. But it also means that Java will display your text even if the font you ask for is not installed. This is part of that portability thing. If you go to run your program on another machine and the font you specified happens not to be installed on that machine, your program will still run. This program runs and displays the text in the various specified fonts. Now, notice this default name for the last line. On this machine, it looks very much like, and probably is, the sans serif font. On another machine, it may be an entirely different font, but it will be the one chosen to be consistent and compatible with the other windows on the system. If you decide you want to write a program that uses the default font on each machine, it's kind of tradition to specify the name of the font family as default. Okay, that's about it for fonts and displaying text. We'll soon be creating special fonts for buttons and pull-down lists, which is only a matter of creating a font object and setting it inside the button or the list. In later lessons, we'll be looking at animating text, but that's only a matter of using the standard animation techniques on what we already know about displaying text. The next lesson demonstrates how to display text in different colors. This lesson is an introduction to colors. Colors in Java are set by creating a color object and then storing the object in the graphics object. Once this is done, everything painted to the window using the graphics object is in the specified color. Java uses a color system on varying the intensity of the 3 primary colors, red, green, and blue. This is sometimes called the RGB system. Each color is stored as a 24-bit value, with each of the primary colors taking 8 bits. With each color value being stored as 8 bits, this means that each primary color can be in the value range 0 to 255. A value of 0 means no color, and a value of 255 means the color is at its maximum intensity. The constructor of the color class requires that all 3 colors be specified. In this example, the color red is created by specifying the red component of the color to be at its maximum and the green and blue components to be completely turned off. The green color object could be constructed the same way, with the red and blue turned completely off and the green component being set to its maximum, and blue works the same way. You can mix 3 primary colors to make any color you'd like. Each of the 3 primary color values can be set between 0 and 255. In this example, red is set to 82, green 167, and blue is 200. The 3 colors are mixed together at these relative intensities to produce a custom color. Just like any other object, to create a color object, you first need to declare a reference to hold its address, which you can do on the same statement you used to create the color, or you can do it ahead of time, like the line of code shown here. You have some choices. There's more than one way to create a color object. To create a new custom color, you can pass it the 3 RGB values, as we have done in the previous examples. Colors can also be expressed as integer values. In this case, the value is written as a hexadecimal number. In Java, preceding a value with a 0 and an X indicates that the characters following it are hexadecimal digits. This particular technique can be useful for copying color constants from other locations, such as HTML, where the colors are always expressed as hexadecimal constants. The 3 RGB values can also be expressed as relative intensities in the form of floating point numbers between the range of 0 and 1. The decimal value of 1 is the same as the value of 255 if you are using integer values. Half intensity for a primary color would be 0.5. For convenience, some of the more common color objects already exist and are there for you to use. These predefined colors are all defined inside the color class and are already instantiated as objects and are ready to be stuffed into your graphics object or whatever else you decide to use it for. Here are the names of the predefined colors. There are a total of 12 of them, including black and white, as well as the 3 primary colors. This may be a good time to mention the fact that not all colors are created equal. Pink on one system will not be the same pink as on another system. In fact, they'll vary quite a bit. Lots of things cause this. The phosphors vary from one screen to the next. The light in the room makes an enormous difference. The colors of the boundaries and other windows on the screen will also cause the human eye to react differently to the colors being shown. And the intensity setting of the primary colors is not linear. That is, red seems to be much brighter than blue if the 2 are set at the same intensity, and some displays try to compensate for this. The degree of compensation varies, causing more color distortion. The bottom line is this: you should try to select simple colors that don't clash and don't worry too much about subtle shadings. This example displays text and uses a color object to change the default color of the background, then displays 3 lines of text using 3 different colors. The constructor makes a call to the setBackground method of the canvas object to change the default color setting that will be used to clear the window before each call to the paint method. Any color could have been used, but this example uses the predefined color named pink. If you don't specifically set the color of the background, Java will use white, just as it has been doing in the previous examples. The first color that we're going to use for text is red. This color could have been produced in any of the ways described earlier, but in this example, the predefined version of the color is used. Since the object has already been created and is ready to use, all we have to do is store it in the graphics object with a call to set color. Once the color has been set, any drawing or painting that you do will be in that color instead of the default black. Here we just draw the line of text. The color for the next line of text is one that we create inside the program. It could be anything, but in this example, the object stored in the MY color reference is actually green. Once the new color object has been stored in the reference, the address of the object is then stored in the graphics object with a call to set color. As you can see from this third example, if you're going to create a color object just for the purpose of storing it in the graphics object, there's no real need to create a reference to it. This call to set color just uses the new command as the argument. This creates a new color object and passes it to the set color method in one command. So now we have a full color window. It may not be very attractive, but that's because I don't have much taste, and besides, this is not a graphics design course, this is a programming course. Notice the background color. I don't know how it looks on your system, but on mine it sure doesn't look pink. To me it's more of an orange, but of course that could be because of the green and blue thrown in with it here and there. Correct color selection is left up to you, and I suggest that you play with the color selections in this example to see what happens when you change color values. A 24-bit color system like the one in Java can produce 16 million colors, but they don't tell you ahead of time that most of them are ugly.